We will start for today's session. Let me share my screen. Okay. I think it is visible, right? Okay.
Yes, ma'am.
Yeah, so let's start. So today what we will do, we will talk about the complex analysis topic, and I have taken 3 questions from different GATE question paper. So the first question is from GATE 2022 physics question paper, and the topic is complex analysis. So let's start. The first question is from 2022. Okay. Yes. So the first question is from 2022, and this is about the complex analysis part, and it is the question number 27. So what is the question? The question is the ordinary differential equation 1 minus x square y double prime minus ax into y prime plus 9y equals to 0 has a regular singularity at which point? And there are 4 options. You can see that there are 4 options are minus 1, 0, plus 1, no infinite value of x. No finite value of x. So these are the 4 options, and we have to calculate at which point we can get a regular singularity from this differential equation. Okay. Yes. So I think so many people have joined later, so I am just repeating the question again. So this is the question from 2022 GATE question paper, physics question paper, and the question number is 27. And the question is the differential equation 1 minus x square y double prime minus x y prime plus 9y equals to 0 has a regular singularity at which point? Minus 1, 0, plus 1, no finite value of x. So this is the question. So first of all, we need to know what is regular singularity, because you can see that in the differential in the question the main thing is regular singularity, and also how to define how to calculate regular singularity, that we have to know. If we can know these things, then obviously we can done the question whatever it is given here. So I have written here some overview. Okay. So I have given one overview here. So for that regular singular point, what I will have to do, and what is basically regular singular point. So you can see here I have written one differential equation. This is a very general differential equation. Here f double prime x plus p1 x f prime x plus p0 x f x equals to 0. Obviously p1 and p0 are the function of x. So this is a very general ordinary differential equation. Now in that case there are 3 cases, like let's say x equals to a. I can say x equals to a as a ordinary point. Okay. I can say x equal to a as an ordinary point. I can say x equal to a as a regular singular point, or I can say it is a irregular singular point. I did not write this irregular singular point because, like, if these 2 conditions will not be satisfied, then only I can tell that okay, x equals to a is a irregular singular point. So what is regular singular point? How do we find that okay, x equals to a is a ordinary point? So for that condition, p1x, p0x, these 2 are analytic at x equal to a. Okay. And what about the regular singular point? If let's say x equal to a is a regular singular point, then 2 conditions should be satisfied. First one is this one, and the second one is this one. So first one is what? First one is p1x has a pole up to first order at x equals to a. And what is the second option condition? p0x. Okay. Yes. So there are 2 conditions for being x equal to a point as a regular singular point. One is P of P1x has a pole up to first order at x equal to a, and the second condition is P0x has a pole of order up to 2 at least at x equal to a. These two conditions should be satisfied for being x equal to a as a regular singular point. What about ordinary point? Ordinary point means P1x and P0x should be analytic at x equal to a. And what about the irregular singular point? If these two conditions are not satisfied for x equal to a, then we can say that it is an irregular singular point. Now in that question they are asking that which point is the regular singular point. Now we have to rewrite that expression a little bit. Okay. So first of all, what we will do, we will write this expression, and after that we will calculate if it has a regular singular point or not, and if it has any regular singular point, who are they? Okay. So the differential equation is 1 minus x square. Let me write this one. 1 minus x square y double prime, then minus xy prime minus xy prime plus 9y. Okay, 9y equals to 0. So this is the expression for ordinary differential equation, and I told you the general expression of ordinary differential equation is f double prime x p1x f prime plus p0x fx, and obviously you can see that from that two conditions we are talking about p1x and p0x. So what we have to do at the very first we have to calculate what are the p1x and p0x. So let us do that one. How to do that? You can see the differential equation whatever I wrote, that is this one. I am just going to write here again so that you can understand that one very clearly. This one equals to 0 f. So that was the expression ordinary differential equation, and I have to calculate, just comparing this with this, I have to calculate p1x and p0x for this differential equation whatever it is given in the question. So how to do that? Obviously you can see here y double prime is there, f double prime is there, then obviously 1 minus x square should be divided throughout the equation, right? Then how to do that? Let's see. X minus 1 minus x square y prime plus 9 by 1 minus x square y equals to 0. Now you can see that y double prime is there, f double prime is there, then there is one term, and now after that there is y prime, this is very similar to f prime, and this is y, it is very similar to f. F is a function of x. Yeah. So whatever the value is there, as it will be as p1x, and whatever it is there, it will be p0x. I think it is very much understandable by all of you, right? So I am just going to extract what is p1x and what is p0x from that given differential equation. Now I am going to write that one explicitly. P1 is minus x by 1 minus x square, and what is p0x? P0x is 9 by 1 minus x square. Okay, so from that equation y double prime minus 1 minus x square y prime plus 9 1 minus x square y equals to 0. From that expression you can obviously tell that how many how many possible singular points are there. So how many possible singular points are there? If I write it is like that, then it will come as x will be plus minus 1. That means our x equals to 1, x equal to minus 1, these two can be possible singular points. But I don't know about the nature of that singular point. Is it regular? Is it irregular? That I have to calculate. Okay, so if let's say 1 is regular singular, then obviously our answer will be 1. If let's say minus 1 is the regular singular, then obviously a minus 1 will be the answer. Okay, so now how to calculate that it is regular singular or not? See, in that condition what I have written here, that P1x has a pole up to first order at x equals to 0 and P0x has a pole of order up to 2 at x equals to a. So a means I got 2 points, one is x equal to 1 and another one is x equal to minus 1. So these 2 points I got from that expression, whatever it is given in the as a ordinary differential equation. So in these 2 points, which one is the regular singular point I have to calculate. So first of all, let us calculate about P1x. In that condition, it is shown that P1x should have one pole of order 1. It is already given here, right? Yes. P1x has a pole up to first order at x equal to a. So let us first calculate first condition. Let us first calculate x equals to 1 singular point. So at that point, P1x has a pole of order 1 or not, we have to calculate that one. Okay. So how to do that? Obviously, to calculate one pole for that P1x term, then what I have to write here, x minus 1 and then P1x. What is P1x? X minus 1 and obviously, just a minute. Okay, I'm just going to remove that. Yes. So limit x tends to 1. Yeah, coming. Just a minute, I'm just coming right now. Sorry. So yeah. Yes. So at x equal to 0, P1x has a pole or not, I have to check that. So how to do that? Like at x equals to 0, x minus 1 P1x and the limit x tends to 1. So let's say I am writing here P1x. P1x was what? P1x was minus something x. Yes. X by 1 minus x square. 1 minus x square I can write like that. So if I do that, then it is like x tends to 1, x minus 1, then x by x minus 1, 1 plus x. So x minus 1 will cancel. Then it will be like x divided by 1 plus x and the limit will be x tends to 1. So what will be the value here? 1 divided by 1 plus 1, which is nothing but 1 by 2. And 1 by 2 is a finite number. So that means we can have a pole at x equals to 1 for P1x of the order 1, which has of the order 1. Pole order is 1. So that means whatever the first condition was there, it is true for x equal to 1 point. Now coming to the x equal to minus 1 point. So what about the x equal to minus 1 point? Similarly, I am calculating for P1x right now. So x equal to minus 1 means x minus 1. So x plus 1. Then minus x, 1 minus x square, x plus 1, x by x minus 1, x plus 1. You can see it is cancelling out. And x by x minus 1. So now, right now x is minus 1. So it is like minus 1 divided by minus 1 minus 1, that means minus 1 divided by minus 2, which is nothing but 1 by 2. So you can see that this is 1 by 2 and it is a finite number. If it is a finite number, obviously that means that we have a pole at order 1 at the for P1x at x equals to minus 1 point. So we can summarize one thing, that x equal to 1 and x equal to minus 1, these two are giving the pole at P1 pole at x, it is giving P1x with pole up to first order. So that means the first condition is satisfied for x equal to 1 as well as x equal to minus 1. For these 2 points, the first condition has already satisfied. Now coming to the second condition. In that second condition, they are talking about that P0x has a pole of order up to 2 at x equal to O. X equal to A. So now coming to that condition. So how to calculate that one? Let's say I am writing here C. So at x equal to 1, at the very first I am considering, and I am considering right now as P0x. And they are asking that the pole should be order of 2. That means at x equal to 1 point, x minus 1 whole square into P0. P0 is what? 9 by 1 minus x square. So if I write that one, x minus 1 whole square into 1 minus x, 1 plus x, or otherwise yes, it is already given. So 1 minus x whole square divided by 1 minus, so wait, 1 minus x whole square, that means x square minus 2x plus 1 into 9 divided by 1 minus x into 1 plus x. So 1 minus x and there was 1 plus, yes, fine. So that also I can write x minus 1 whole square 9 by 1 minus x square, yes, 1 minus x square. So x minus 1 whole square 9, 1 minus x, 1 plus x. So x minus 1 whole square 9 divided by minus of x minus 1, 1 plus x. Then you can see that I can just cut out 1 minus x from here, then 9 into x minus 1 by minus of 1 plus x. So this is the result. And if I just put the x equal to 1 point, then what will be the value here? Obviously it will give a 0 value, because 1 minus 1 is 0. So that means at x equals to 1 point, I have a finite value which is the 0. That means it has a pole of second order at x equal to 1 point for P0x. Now coming to x equal to minus 1 point. So for that case, let's say x equal to minus 1, and there is, I am talking about P0x. So what will happen for that? X plus 1 whole square 9 by 1 minus x square, yes. So x plus 1 whole square 9 by 1 minus x, 1 plus x. You can see 1 plus x will cancel out, then 1 plus x into 9 divided by 1 minus x. And we are talking these things at x equals to minus 1 point. So if I put the x equals to minus 1 point, then what will be the value? The value will be 0, which is again the finite value. That means at x equals to minus 1, at this point P0 has a pole of order 2. Okay, so we can see whatever we have seen in that expression, that for to have the x equal to a point as regular singular point, P1 should have a pole up to first order at x equal to a. P0 should have a pole of order up to 2 at x equal to a. These two conditions simultaneously are satisfied for x equal to 1 and x equal to minus 1 for this differential equation whatever given in the question. So that means our answer of that question will be minus 1 as well as plus 1. So A and C both will be the answer for that question. Regular singularity can have at x equal to minus 1 as well as x equal to plus 1. At these 2 points regular singularity we can have for that differential equation. So this is the first question. If you have any doubt, you can just ask me, or we will discuss that one in last also, like when we will finish these whole questions. Basically we are just calculating at each and every singular points the value of pole. Is it, the value of P0, P1 or whatever, is it giving the finite value or not? If it is giving the finite value, that means it has a pole at that point according to the order whatever we are taking. That's it. If it is giving a pole then we can say that at that point it has a regular singular point. Okay, so now yes.
Can you please show the statement?
Can you please show the
statement?
Statement, yeah, sure.
Yes.
Yes. I just want to remove that one.
So here the last one, like P0 is as a pole of order up to 2. So that means that we can also have a order 1.
No. Up to 2 means obviously it will be at 2. Sorry, yeah, like up to 2 means it will be at 2. And if you also calculate like that, then you just calculate, and what will happen you have to tell me. Let's say I am like writing that one, n by 1 minus x square. Then what will be the value at x equals to 1, let's say. So what will be value here? 1 minus x, 1 plus x, right? And there will be 1 minus, let's say it is like minus 9 by 1 plus x. Then also if you have n x equals to 1, then what is the value coming here? Minus 9 by 2, which is again a finite value, right? And just coming to the x equal to minus 1 case also. X equal to minus 1 case. So for that, x plus 1 divided by 1 minus x, 1 plus x. So 1 plus x will cancel out. Then n by 9 by 1 minus of minus 1, that means 1, that is 9 by 2, which is a finite value. So up to 2 means obviously when we are talking about up to 2, that means it should be it should satisfy the first order also. I mean at most it can satisfy up to second order, that is the case. So for first order we can obviously do that one, as I told you right now. Just do that one, then you can have a feeling that okay, up to first order also it is giving the pole. So up to second order it is giving the pole or not, that is the main thing we have to check.
Okay, ma'am. And then to check the order of a pole, so can't we just say from the expression of P0 and P1, do we really need to calculate the residue?
Okay. So like as let me tell you the expression again. Okay, you can see that P1x is minus something x, x, 1 minus x square, and P0x is 9 by 1 minus x square, right? So obviously from that expression you can see that x is plus minus 1. 1 will be there or minus 1 will be there. So from that expression I can directly tell that plus 1 or minus 1 should be the regular singular point. Singular point. But which one is the singular point, regular singular point, that I have to check. So for checking this one we have to calculate that first order and second order calculation of pole. Otherwise how can we tell that it is giving the finite value or not? But only seeing these expressions I can tell that x equals to plus 1 and minus 1 is giving the singular point. That I can tell. But which type of singular point it is, that I can't tell from that expression directly. Okay. So for that we have to do the calculation so that we can have a knowledge that okay, this is the regular singular point, this is the irregular singular point, or something like that. Let's say in any case, let's say in this case x equals to minus 1 is giving us at the second order of pole, it is giving us an infinite value. Then we can't say that x equals to minus 1 is the pole. Regular singular point. So to see this one we have to calculate that one. But it's a very simple calculation, like I am just talking as a very detailed calculation, but you can calculate directly also. That is a very simple, like you just want to do the simple calculation, x minus 1 whole square into 9 by 1 minus x square, and then you have to just divide 1 minus x square by this expression, and you have to put x equals to minus 1 or plus 1 according to your expression. Then if you get a finite value, then it's fine, or if you getting a non-finite value, then it is irregular singular point. It is not a regular singular point. That is the case. So yeah, what is the singular point? By seeing I can tell that, but for regular and irregular singular point we have to calculate that one. So is there any other question? And yes, obviously for P2, P0 there should be first order as well as the second order pole should be there, and for P1x the first order pole should be there. And if obviously the second order pole is there, that means the first order pole is obviously there, as we have already seen from that expression. Right now I did that one. So yeah. Okay, so I think we can go to the next question. Okay. So in the next question, the next question I have taken from GATE 2021 physics paper, and the question number is 16. Yes, the question number is 16. So what is the question here? If y and x is a solution of the differential equation, this is the differential equation, y double prime minus 2xy prime plus 2ny equals to 0. So this is the differential equation. So in the differential equation where n is an integer and the prime denotes differentiation with respect to x, that is very simple. Then acceptable plots of y and x will be what? And y and x is nothing but e to the power minus x square by 2 into y and x. Psi and x is e to the power minus x square by 2 y and x. So basically what they are asking, from that differential equation we can have a value of yx, right? And with that yx value, if I just put in that expression that psi n x equals to e to the power minus x square by 2 into y n x, then we can have a expression like f of x will be like something into x, something like that. We can have a expression like that. And what will be the plot for this expression, we have to tell. And there are 4 options it is given here. One is, you can see that it is the plot between psi n x and x. So the plot is for x equals to, for n equals to 0, the plot is in the first option it is giving the straight line. For B it is giving this type, and then for C it is giving like that. And obviously you can see that the n number is given also here, n equals to 0 and n equals to 1. And for D option it is n equals to 1 and the plot is like that. So this is the case, this is the question. I think you have understood the question clearly, that we have to calculate, we have to tell what will be the nature of this function. Psi n x will be psi n x equals to e to the power minus x square by 2 y n x. What will be the nature of that equation? Okay, so I am just going to write this one a little bit clearly. Minus 2 n x y prime x, then plus 2 n y 2xy. Just yes, 2xy prime 2ny, 2xy prime plus 2ny equals to 0. I think if you have heard about a Hermite polynomial, then you have seen that one very clearly. Like, this is nothing but a Hermite polynomial, is it? If you have the knowledge about the Hermite polynomial, then Legendre polynomial and all these things, you can see that this is nothing but the differential equation for Hermite polynomial. So if it is like that, then obviously we can have the expression for y coming from the Hermite polynomial expression. So what is the expression? Let's say h n x. I think all of you have heard about these things, Hermite polynomial. So in that Hermite polynomial, as in that question they are asking about n equals to 0 and 1 only, then we don't need to calculate all the nth terms. We just need to have the knowledge of these two, n equals to 0, n equals to 1. Then you can see n equals to h0x is what? h0x is 1. h1x is what? h1x is 2x. So we just need to remember these two, h0x is 1, h1x is 2x for this question at least. So as I told you, this is nothing but a Hermite equation, Hermite polynomial differential equation. Then the solution of that equation will be, at n equals to 0 it will be 1, at n equals to 1 it will be 2x. Okay, now in that question they are asking that psi n x is e to the power minus x square by 2 y n x. Fine. Now I am calculating at the very first n equals to 0. At n equals to 0, psi 0x will be e to the power minus x square by 2 y 0x. Now what will be the value of y0x? I have written here y0x is nothing but 1. So if I just put here minus x square, e to the power minus x square by 2 into 1. So this is e to the power minus x square by 2 and this is psi 0x. So this is the plot, this is the expression for the n equals to 0 mode. And now all of you knows that what will be the nature of that expression, that psi 0x is e to the power minus x square by 2. It will be nothing but like that, right? So at n equals to 0, because e to the power minus x square by 2, in x square by 2, that means obviously whenever x is plus or minus, it will give a positive value. X square is given here. So that's why e to the power minus x square by 2, it is giving that type of nature, because this is the peak point and after that it will decrease as e to the power minus x like thing, x square like thing, and it will also decrease in that negative y axis also. So this is the plot for n equals to 0 term. Now we have to match this with this. Now you can see here this is the 0 point, and here you can see from here to here there is a decreasing nature, and here to here also there is a decreasing nature. So that means the B option will be the correct one for n equals to 0 mode. Now coming to n equals to 1 mode. So psi nx was e to the power minus x square by 2 into yx, ynx. Now at n equals to 1, at n equals to 1, h1x was what? h1x was 2x. Now we just need to put these values here. E to the power minus x square by 2, then y1x, e to the power minus x square by 2 into 2x. Now you can see our psi 1x is there and it is like 2x e to the power minus x square by 2. This is the expression, and we have to think about this nature of, this expression nature. What will be the nature of this plot? See here there is x and we are talking about n equals to 1 condition, and it is psi 1x. So when, let's say it is 0. So when it is 0, then it will give us 0 value because x is there. Now whenever we are going in the positive direction, that means x is positive value. So if it is a positive value, then it is increasing due to x, right? And after some time it will be decreasing due to this term. This is an exponential decreasing function. So it is like that, and after that at a certain value it will decrease. Now coming to x equals to minus value. When x is minus value, then obviously due to this value it is going down. But after some time, due to this one, as it is x square term here, then it will be like this. So the nature will be like from 0 it will start, it will increase, after that after some time it will decrease, and here it will decrease, and after some time it will increase. So it is psi x, it is psi 1x, and it will be for n equals to 1 case. Now we have to compare that one, whatever it is given in that question. Now you can see, as I told you, at the 0 point it will be 0, and after that it will increase due to x, because it was e to the power minus x square by 2, and 2 was there also, but 2 is nothing but a constant factor. So it will increase, and after that after some time it will decrease again as e to the power minus x square exponential decreasing function. For here also it will come as minus x, then it will also up as e to the power minus x square by 2. So this will also be the correct one. So from that question we can conclude the correct answer will be B and C. So, but the main thing is that there is a very simple trick. Whatever they have given as differential equation, it is nothing but a Hermite polynomial. So by knowing that knowledge, we can directly say what will be psi 0x and what will be what will be y0x and what will be y1x. So I am just directly putting that one, and I am just getting that result. So is there any problem on that question, or should we move on the next one?
So we are simply taking that value of h1 of x and h0 of x from the equation itself, right?
Yes. So h0 x, h1 x, nothing more than that we are taking, because h is the solution of the differential equation. I mean, we are talking about h because it is a Hermite polynomial, but we can, for this expression, we can directly write like that: y0 x is 1, y1 x is 2x. So we are just directly calculate that one by putting this, by putting y0 x and y1 x in that expression. Psi n x equals to e to the power minus x square by 2 y n x. Now we get the nature of that plot, that like psi 0 x is e to the power minus x square by 2, and obviously you all know that what will be the nature for e to the power minus x square by 2. It is like that. And for what n equals to 0, it is psi 1 x is 2x e to the power minus x square by 2. So it is nothing but x e to the power minus x square by 2 nature. So how it will be? It will be like from 0 to 0 it will start and it will go up, and after some time it will go down. Similarly from here to here and there to there. So this is the nature for that n equals to 1 plot. So by seeing that these plots, we can just confirm that B and C option will be the correct one. Okay. So should I move to the next one? Okay. So this is the next one. So in the next one, I have taken the same question paper 2021 physics, and I have taken 50th question. And the question is, yes, the question is a contour integral is defined as In, which is contour integration, closed contour integration dz divided by z minus n whole square plus pi square, where is n is a positive integer and c is the closed contour as shown in the figure, consisting of the line from minus 100 to 100 and the semicircle traversed in the counterclockwise sense. And you can see the picture here, that in that x-axis it is going from minus 100 to 100, in between it is 0, and in the y-axis it is coming as counterclockwise semicircle, and it is already mentioned that z will be x plus iy. The value of summation n equals to 1 to 5 in integer is what? So this is the question. I think it's understandable, right? We are just going to calculate a integration of a complex variable. That is the thing. And the complex variable is what? If z equals to 1 by z minus n whole square plus pi square. And there is a condition that we have to calculate that one up to n equals to 1 to 5. I mean, that will be summation of n equals to 1 to 5 and in. That is the main thing. Okay. So we are just going to do that right now. Let me do the figure at first. This is x, this is y, this is 0, this is minus 100, this is plus 100. It is coming counterclockwise. Okay, now I am just going to write here in. In is what? In was dz divided by z minus n whole square. Okay, z minus n whole square plus pi square. So this is like this. Now first of all, I just want to calculate fz. Fz is nothing but z minus n whole square plus pi square. So I am just going to do a little bit mathematics inside of this. If I write like that, z minus n whole square minus I pi whole square. Okay, see, I pi whole square, I square is minus 1, this minus 1 and minus 1 will come as plus 1, whatever it is given here. So why we have taken like that? It is nothing but a square minus b square expression. So a plus b into a minus b. Okay, so our fz is coming like 1 by z minus n plus I pi z minus n minus I pi. Now you can definitely see how many poles are here. I mean, how many singular point is there. One point is z1 is like n minus I pi. It is coming from this term, and from this term I can have another singular point which is z2 equals to, let's say I am talking about z2, it is n plus I pi. Okay, I think up to this there is no problem. So z1 is n minus I pi, z2 is n plus I pi. These two singular points are there. Now we have to check in this plot which singular point will be present. So I am just going to draw that one again. It was in, I think. What was that? Oh, y, sorry. It was y. Then from here to here I am going. It is like anti-clockwise, and it is minus 100 to plus 100, and it is 0. Now we have to think among this point and this point, which point will lie in that contour. First of all, just see this one, n plus I pi. N is an integer, right? So n is an integer as well as it is a positive integer. And also whatever they are asking about in, which is n equals to, okay, they are asking about n equals to 1 to 5. That means it is obviously a positive integer, right? So n is a positive integer. So if I write n plus I pi, that means I am going for x as a positive value, y as a positive value, because pi has value 3.74. I mean 3.14159. So this is also a positive value. So you can see that this, in that coordinate it is falling. This point is falling in that coordinate, positive x, positive y. So in that coordinate the point is lying, and obviously as it is up to 100, that means n equals to 1 to 5 obviously will fall in that region. I mean whatever the region is I am surrounding right now, in that region obviously it will fall. So that means in that contour this point will lie. Now coming to n minus I pi, and n is 1 to 5. So x is for that case positive, but y is negative here, because you can see here, if I write n minus I pi like n minus like that, so y is minus pi, and minus pi means it is minus 3.14159. That means in which quadrant it will be? It will be in the quadrant of, this is plus and this is minus. That means in that quadrant the point will be lies. N minus Iy will lie in that quadrant. But we are considering only this quadrant from 0, minus 100, 100, and in that quadrant n plus I pi point will be there, and in that quadrant n minus I pi point will be there. So you can definitely see that this point will be excluded from our contour, this point will be included in our contour. So to calculate the integration for this case, we have to take only this point. We will not consider this point. I think it's understandable, right? So we are just talking, we will talk about this point only. Now coming to the fz again, fz was 1 by z minus n minus I pi z minus n plus I pi. And right now we will consider about n plus I pi point. No other point we will consider. Okay. So now what will be the integration value? At the integration, you know that, like, let's say z minus z0 and then fz at z0, fz. So if I calculate that one, then what will be the value? And obviously limit z tends to z0, and there will be one 2 pi I also, but I will multiply the 2 pi I later. You can also multiply that one right now also, but yeah, fine. And right now our z0 is what? Z0 is n plus I pi. Now I am writing here n minus I pi, and fz is z minus n minus I pi, z minus n plus I pi. Then you can see that this one and this one will cancel out, so z minus n plus I pi, and we are taking the limit as z going to n plus I pi. So if I put the value, then what will happen here? It will be like n plus I pi minus n plus I pi. Now what will be the value? The value will be 1 by 2 I pi. And as I told you that in will be 2 pi I into 1 by 2 pi I, because the integration formula is like z minus z0 f of z, and there will be one limit z tends to z0. I did this expression at the very first, which is giving as 1 by 2 pi I, right? So our in will be what? 2 pi I into 1 by 2 pi I, which is nothing but 1, right? So I am getting in equals to 1, but in that question they are asking this one. They are not asking about in, they are asking about this one. Then what will be the value of this one? See, in is 1. In is 1 means the meaning of this is like whatever the value of n is there, the integration will be 1 value, will give 1, right? So that means I1 is 1, I2 is also 1, I3 is 1, I4 is 1, I5 is also 1. Now coming to this expression, whatever they are asking that summation over n going from 1 to 5 in. Then what will be the value? I1 plus I2 plus I3 plus I4 plus I5. So the answer will be 1 plus 1 plus 1 plus 1 plus 1, which is nothing but 5. So from that question our answer is 5. Do you understand that question? Like most of the people will do like in equals to 1 I am getting, so they will write the answer as 1, but the answer is not 1, because they are not asking in, they are asking this one, summation n equals to 1 to n in, and as I am getting in will be 1, which is not a dependent function on n. You can see in the right hand side there is a constant value, it is not dependent on n. So whatever will be the n value, it will give the same answer. So in equals to 1 means I1, I2, I3, I4, I5 all will have 1 value. So if I write this one, then it will be the summation of these 5i, and it will give us 5 value. Do you understand the point? I think yes. So up to this we did for today, and I explained 3 questions from complex analysis, and it was from 2021 and 2022 question paper, physics question paper. And if you have any doubt on these 3, then you can ask me. I am just going to show these 3 questions again so that you can have a look. So this is the first question. Ordinary differential equation is there, and it has a regular singularity at which point? The answer is -1 and +1. Now coming to the second question. Yes, if y and x is a solution of the differential equation y double prime minus 2x y prime plus 2ny equals to 0, where n is an integer and the prime denotes the differentiation with respect to x, then acceptable plots of y and x equals to e to the power minus x square by 2 y and x is or are which one? And there are 4 options. You can see that the correct option will be B and C, because in n equals to 0 that type of plot is there, and n equals to 1 that type of plots is there. Now coming to the third question. A contour integral is defined as in equals to closed integration of over c dz divided by z minus n whole square plus I square, where n is a positive integer and c is the closed contour as shown in the figure, consisting of the line from minus 100 to 100 and the semicircle traversing the counterclockwise sense. The value of summation n equals to 1 to 5 in integer is which value? I mean, what is the answer of that? So I just forgot. Tell me.
Please explain first problem, ma'am.
First problem. Just a minute. I just forgot to write here one thing. Yes, this one. This is dz. I mean, like, obviously.
Now, in the third question, what is the significance of the detection of?
What is the?
So here, what is the significance of the under the semicircle is traversing the counterclockwise sense?
Yeah, in the counterclockwise sense also only we can write that one, 2 pi I integration fz. Z minus z0 dz. This one. This is the in value. This is the in expression, right? So the in complex calculation, whatever the contour is there, if it is a counterclockwise calculation, I mean counterclockwise contour, then only we can have the expression of that integration as 2 pi I limit 2 pi I limit z tends to z0 fz z minus z0 dz. Sorry, it will not be z0. This is like that. I did that one. Like the integration function will be like 2 pi I limit z tends to z0 z minus z0 f z. This is the case, and it will only possible if we have a counterclockwise contour. And why is semicircular counterclockwise circle? I mean contour, because you can see that I told that n minus I pi, n plus I pi is there. So n plus I pi will fall in that region, n minus I pi will fall in that region. If it will be a circular form, then also n minus I pi also, this point also we have to take care. But as it is a semicircle, we don't have to take care n minus I pi point. We just only need to take this point n plus I pi, so that we can have the result, because n minus I pi is not inside of that contour whatever we are considering. Only we have n.
And if the semicircle is traversing the clockwise direction, then the formula.
Then yes. So like then for what? Like what? Let's say it is like from here to here. Okay. So it is like here to here. So what we have to do? We have to put a minus sign so that it will go. Like there will be a minus sign in front of the expression so that we can have it will as a anti-clockwise direction. But as it is by default giving as a anti-clockwise contour in that equation, so we don't need to do any minus sign here. Okay, so one student was asking about first question. So should I explain from the very beginning of the first question, or do you have any specific question on that first question?
Beginning, ma'am.
Beginning. Okay. Okay. So I'm just doing a very quickly. Okay. So you can see the question at first. The question is the ordinary differential equation is this one, and it has a regular singularity at which point they are asking. Okay. So in the ordinary differential equation, I am just going to write the differential equation at the very first. I have written here 1 minus x square y double prime minus ax y prime plus 9y equals to 0. Now they are asking about regular singularity. So what is the condition for the regular singularity? There are basically three types of points. One is ordinary point, another one is regular singular point, and another one is irregular singular point. I did not mention here irregular singular point explicitly because if these 2 points will not be satisfied, then obviously the point will be irregular singular point. Okay. Now coming to the regular singular point, as in that question they are focusing on regular singular point, we have to do something on regular singular, like we have to tell that this condition and this condition is satisfied or not. There are two conditions given here. What is the condition? The condition is like, if our ordinary differential equation is like f double prime x plus p1x f prime x plus p0x f0x equals to 0, if it is in that form, then for regular singular point, if p1x has a pole up to first order at x equals to a, and p0x has a pole of order up to 2 at x equals to a. So these two conditions we have to satisfy simultaneously at x equal to a point. If these conditions are satisfied simultaneously, then we can say our x equal to a point is a regular singular point. Okay, so this is the overview. Now coming to the question, I mean whatever it is given here in that question. In that question, 1 minus x square y double prime minus x y prime plus 9y equals to 0. So for that case, you can see, to compare with this expression whatever I have given in that general expression, we have to first calculate what is p1x and p0x, so that we can say that p1x has a pole of up to first order or second order or not, or p0 has a pole of up to first order or second order or not, then only we can say. So what is p1x and p0x in that question? If I just compare these two, then we can see our p1x is minus x by 1 minus x square and p0x is 9 by 1 minus x square. So these two are p1x and p0x. I have written here explicitly p1x and p0x. Now in that question, by seeing these expressions, we can definitely tell that which singular point we can have. 1 minus x square will be 0, that means x equals to plus minus 1. So 2 points can be regular singular point. One is x equals to 1 and another one is x equals to minus 1. These two can be regular singular point. Now we have to calculate for each and every case that p1x has a pole of order 1 or not, p0x has a pole of order 2 or not at these 2 points. Now first of all calculate x equals to 1. I have written here a. So at x equals to 1, if p1 has a pole of order 1, then the expression is like limit x tends to 1 x minus 1 into px should give us one finite value. So I am writing here and calculating that one. If I put x equals to 1 value here, then I am getting 1 by 2. So if I am getting 1 by 2, that is a finite value. That means at x equals to 0, p1x has a pole of order 1. Now coming to x equals to minus 1. Similarly, I have doing the same thing and I got an answer as 1 by 2. 1 by 2 is also again finite value. So if it is a finite value, then also I can tell that at x equals to minus 1, p1x has a pole of order 1. Now coming to the second condition, that p0x. p0x should have a pole of order 2 at x equals to a point. So I am talking here 2 points, x equals to 1 and x equals to minus 1. So at the very first x equal to 1. So if it has a pole of order 2, then I have to have that expression that limit x tends to 1 x minus 1 whole square into p0x should give a finite value. Now if I calculate this one a little bit, then I am getting the result as 0. And you will know that 0 is a finite value. That means at x equals to 0, p0x has a pole of order 2. Now coming to the next one, at x equals to minus 1. Similarly also, if I calculate for x equals to minus 1 to p0x, I am getting 0 value. That means also again it is a finite value. So at x equals to minus 1 also, I am getting p0x has a pole of order 2. So you can see whatever I was writing in that expression, that is exactly satisfied for these two conditions and for these two values x equals to plus 1 and minus 1. That's why we can say x equal to plus 1 and x equal to minus 1 can be a regular singular point for the differential equation 1 minus x square y double prime minus x y prime plus 9y equals to 0. So that's why I can have two answer for that question, x equal to plus 1 and x equal to minus 1. Is it understandable?
Yes, ma'am.
Okay.
Then what is mean by pole of order 1 and pole of order 2?
Okay. So, yes, this one. Let's. Can you see the screen? I think it is going blank, but yeah. So, x minus. Oh, I can't write it properly. Okay, I am telling that one. X minus x0 to the power n p1x or p0x whatever. If it is giving a finite value, then it has a pole of order n. Okay. So now I am talking about x minus x0 to the power 1 into p1x. That means it has a pole of order 1. X minus x0 to the power 2 into p1x. That means p1x has a pole of order 2. Okay, the general expression is x minus x0 to the power n into p1x or p0x whatever I am talking. And the limit will be from x to x0. So whatever the n value will be, according to that we can tell this p1x or p0x has a pole up to that much order. Let's say if n equals to 3, that means up to third order. If n equals to 4, up to fourth order, something like that. And yes, obviously if just wait. And if obviously if it is a up to second order I have a pole, that means obviously we have a pole at first order also, because I already calculated that one also, that like if p for p0 case, if I have x minus x0 into p0x limit extends to x0, then also we can have one expression which is finite value. That means our n equal for p0x x equals to for p0x the pole will be at order 1 as well as the pole will be at order 2. Okay, like this is the condition for the regular singular point. That is the thing. p1x should be of p1x should have a pole of order 1, p0x should have a pole up to order 2. That means obviously up to order 1 also it should have a pole, as well as obviously up to order 2. But also again you can see that if I calculate x minus x0 whole square for p1x, then what will happen? You can try that one, and you can just say that that is not the case for regular singularity condition, but you can also try that is it a pole or not for second order. Okay, like it's for your curiosity or something. But the general expression is x minus x0 to the power n, limit extends to x0, and there will be p0, p1 or whatever for getting that type of nth order of pole.
Madam, if numerator is in trigonometric form, ma'am?
Numerator?
Is in trigonometric form, which formula we have to use, ma'am? Trigonometry, sin x, cos x, cot x.
For what?
For example, integral cos z minus I prime.
I can't hear you properly. Can you tell me again?
For example, integral cot x, ma'am. Cot zx. By z minus a.
Can anyone hear him properly? Sorry. As per I understand cot x. Oh, my laptop is getting stuck. Cot x of
By
hello.
He's saying cot x divided by z minus a.
spot. Something is there in chat box. My system is getting hung, so that's do we need to memorize the Hermite polynomials? Can we calculate it on the spot? Okay. Only Z2 parts are the lines outside the contour, lies inside the contour, Z1 outside the contour. Yeah, good. And yeah, do we need to memorize the Hermite polynomials? Can we calculate it on the spot? Yeah, you can obviously calculate it on the spot, but the main thing is like if you remember that one Hermite polynomial differential equation form, then you can done within a second, within a minute or something like that. So, can you hear me? Hello? Can anyone tell me, am I audible or not? No, I'm not audible. Network is bad. Oh, sorry. Now can you hear me? Okay, so whoever asked the question, I did not hear the question properly, the last question, that cot x or something. Maybe he was talking about cot x divided by 1 minus something like trigonometric function there he has mentioned, I think. So yeah, I did not hear properly, so sorry for that. But yeah, there is one question I just wanted to tell you, that Hermite polynomial, we need to memorize or not? If you memorize that one, that is very much helpful for you, because there is only there is only 3 polynomials there in your syllabus, right? Legendre polynomial, Hermite polynomial, and Lagrange polynomial, and Lagrange polynomial is also there. So these 3 or 4 polynomials are also there, only there in your syllabus. So memorize that one. In your GATE question paper, you can see one of them can have with a question. So if you just memorize that one, that will be helpful for you. Okay. Hello, am I audible? Okay, I think we will just stop today's question. My internet is a little bit fluctuating, so we will meet in the next class. Okay.